Wired and wireless channels. A communication channel is the medium used to transport information from one network device to another. And there are two broad types of channels. One are the wired channels, which transport data through physical wires and cables. Also using this term here very broadly, data as information or signals. Wireless channels transport data from one device to another via radio signals or other electromagnetic frequency. Channels require devices, the technological pieces of physical entities, and also, once again, the standards or the logical programmatic manipulation of the data for generating and interpreting the signals. So there's both always hardware. This is kind of what I'm getting at. This is the hardware and the software. Here's an image of the electromagnetic spectrum, just so we have some kind of context to understand the size and the kind of type of communication that wireless channels involve. So usually wireless and wired channels actually, but wireless channels usually will communicate information in the radio waves, sometimes also here around the microwaves. And these are frequencies within this range here, 10 to the 4th to 10 to the 8th hertz. These are fairly large waves. If you were to visualize them, usually they're invisible to the eye, but if you were to visualize them, they're the size between humans and buildings. So they're very large waves that can actually go very far distances depending on the specific frequency itself and the devices that are emitting them. Let's talk a little bit about wired communication. So wired channels include different kinds of cables, and I will just discuss some here that I'm more familiar and commonly used. So one are the twisted pair wires used for telephone landlines. So cables like the telephone cables and the Ethernet cables or network cables that you're familiar use this twisted pair technology for transferring electromagnetic signals. There are the coaxial cables used for cable television networks and also broadband communication. They have a greater bandwidth, so they enable more information to be transferred per unit of time. And then there are the best of the best in terms of amount of data and speed that information can travel through, which are the fiber optic cables. And as the name suggests, these cables actually transmit light. So whereas the coaxial cables transmit voltage in the electronic signals, the fiber optic cable actually uses light. And there's some references here if you want to look deeper into this. Benefits of wired communication. So wired connections are generally more secure than wireless connections because of the difficulty of interception. The wired connection has that one wire that to be intercepted or somehow disrupted would need the physical connection to the wire. A wireless connection can be intercepted because the radio waves are in the air and other devices may connect to it or somehow hinder it or disturb it. Wired connections are generally more dependable than wireless for kind of similar reasons I just mentioned. Their carrying capacity and speed are not affected by airborne interference from rain, snow, or electrical devices. Now, of course, the wireless device in your own house may also be protected from rain, snow, or other airborne interference. But if outside of your house, which the communication needs to go to if you want to access other computers outside of your home. This is not the case. So, but I should just kind of highlight some here. You should recognize that data may travel through both wired and wireless media, right? So just because your home computer or your office computer is connected via a wire to your office network, it doesn't mean that through other points in the travel of your data, it's also wired. Part of it can be wireless, part of it can be wired, and so on. So they often both working together. Disadvantages of wired connection. In wide area networks, wired installation can be costly because cables have to be suspended from poles or buried underground, and they can be damaged by weather, and repairs may require heavy equipment to locate, access, and fix the break. So whereas in the wireless communication, the transmission of signals themselves can be damaged. In the wired connection, the cables themselves, of course, they are also potentially damaged by weather or other kinds of events like this. Local area networks devices connected by cables have limited mobility. So once you set up the cable from the internet service provider in your neighborhood to your house, that they kind of staying there, and it's kind of hard to just change them as needed. Cables can be unsightly, tend to get tangled and collect dust. So running cables through ceilings, walls, and floors can be challenging. Cables can carry electrical surges that could damage network equipment as well. So there are some pros and cons to both wired and wireless connections. Wireless communication. The most widespread wireless channels for communication networks are radio waves and microwaves. Most wireless channels transport data as radio frequency signals, commonly called radio waves. Radio frequency signals are sent and received by a transceiver, a combination of a transmitter and a receiver that is equipped with an antenna. And here there's an image of a cellular network with this kind of illustration here of a radio signal. Actually, this is more like probably like a microwave signal, because the microwave is more directed, where a radio signal is actually more round like this. Of course, this is invisible to the eye. We don't see it, but they are there and they can be detected. And of course, they work. We see it working all the time. Any device communicate wirelessly via radio signals needs to have some type of transceiver in the device. A transceiver, once again, has an antenna, which may be visible or may be housed out of sight within a device's system unit. Here I have some images of a Wi-Fi router. There's some other kind of potential like walkie-talkie device here. Here's an image of a regular smartphone going inside a smartphone. There are several antennas. Now the antenna is tiny, it's just a little piece of metal here and there, but they're there nevertheless. There's several antennas. There's antenna for the Wi-Fi connection. There's a potential antenna for the 5G. There may be multiple antennas for the 5G. There might be other kinds of antennas, either to support the other antennas or to do different kinds of connections. Diversity antennas, I'm not sure which ones these are, but there could be multiple antennas for different kinds of connections, perhaps a Bluetooth antenna, and so on. So your device has various types of antennas and various ways to be sending digital signals all the time. Wireless communication, a little bit more. So microwaves, waves at the microwave range, provide another option for transporting data wirelessly. Usually they are at the radio. We usually work with radio waves. So even though we talk about radio, just the radio waves use radio, but also Wi-Fi and cellular networks also use radio waves. Microwaves are electromagnetic signals that can be aimed in a single direction and have more carrying capacity than radio waves. Microwave installations usually provide data transport for large corporate networks. I think they're more expensive and more difficult to work with, but they also have some benefits and may be employed in some specialized settings. Some advantages of wireless, of course, mobility, there's no cables involved, less susceptible to power spikes. Now there's a disadvantage of wireless. The speed can be less than the wired. Now, this of course depends on several other factors like the computer, the internet service provider, and so on. The range is usually shorter. The security and reliability of the connection itself is generally less than wired communication. So there's several disadvantages. I put health here potentially because of some things I have been reading, but I just pointed out here just as food for thought, maybe challenge your thinking a little bit on whether or not the amount of wireless communication everywhere has any impact on us. And you can kind of look into this a little bit. There's some interesting research on how wireless communication can actually impact human cells and cells of animals and so on. A little bit more on communication channels here. Let's explore this a little bit deeper. So communication channels are often assessed or explained or categorized based on a number of criteria and properties which are important to know. So these are the frequency bands, so sometimes also called channels. Although channels has a kind of few different definitions, but they can be the frequency band, can have channels within the bands. So I will use these terms a little bit loosely here. The frequency range and the bandwidth, which is the carrying capacity. And actually, there's a kind of image here I was able to find from the internet and kind of explaining some of the difference between the 4G antenna and the 5G antenna. And actually, it actually has some of this information here that you see. So the frequency that 4G operates versus the frequency that the 5G. So frequency is the, well, this would be the frequency range, but the bands are, it's kind of similar. The bands are the bands within the frequency range. It's kind of like the different areas within the range that are often used. And the bandwidth, sometimes called the network speed, also here to compare the two. So the frequency range is the range of frequencies at which the waves are transmitted. These are measured in hertz, megahertz or gigahertz. Wi-Fi devices, like other devices, may offer multiple bands at different frequencies, and different devices will work at the different bands. So they're all using the same technology. It's using frequencies within a particular range that define that technology, but there are multiple bands that any one particular device may be operating at. And here's an image actually of a Wi-Fi bands. And generally, the higher the frequency, the higher the data transmission, but worse the spatial reach. So the higher the frequency, the higher data transmission, but less reach spatially. Bandwidth is this transmission capacity of a communication band or channel. And that's usually measured in bits per second, also called network speed. Network bands that are capable of moving at least 25 megabits of data per second are classified as broadband. And so channels slower than 25 megabits are classified as narrow band. For perspective, you can see here a 4G cellular antenna has a network speed of 150 megabits per second, and the 5G is 10 gigabits per second. So substantially more than the minimum to be considered a broadband. Now, of course, once again, your actual connection speed depends on various factors, your ISP, your computer processing speed, the computer that you're connecting to, and so on. A little bit on the devices that are connected to the network. So any device on the network is called a node, and this can be a computer itself, but it can be a printer, it can be a refrigerator, it can be a router, it can be a car. It can be a watch and so on. A router is a device that controls the flow of data within the network and also acts as a gateway to pass data from one network to another. Here's kind of an image of an actual router, like your potential wireless router that you're at your own home. And it, as the name suggests, it routes information. So it enables various devices to connect to one other network or point of connection. And these can be wired or wireless. So the router, there are fixed physical wired routers as well as wireless. The modem contains circuitry that converts the data carrying signals from a digital device to signals that can travel over other communication channels. So the modem, what the modem does is translate the communication from the computer, the digital device, into the coaxial cable that needs to be used to continue that transfer of data. So the data in your computer, the binary data and transistors and so on, the processing is a little bit different than the data that has to be transmitted over the coaxial cable by using kind of a voltage. So the modem does that work of translating the digital data into voltage data to be transmitted over that cable itself. For that to happen, there needs to be what are called communication protocols, and which are the set of standards for transmitting data from one network node to another. Networks use more than one protocol, and the collection of protocols for a network is referred to as protocol stack. So the protocol is the standard or the manner of which information is being transferred. And we're going to talk about it. There are different layers, both once again, everything is happening at the software level, which is kind of more like the logical level, and also the hardware level, which is on the physics of the technology itself. Here's an image that illustrate the connection over the web. As we're going to talk about, the web is a protocol of the internet. So the web is not the same as the internet. The web is a way of connecting through the internet, and the web has its own protocol for how data is to be transferred. So when you open a web browser, this is an image of a web browser. The web browser has its own protocol for transferring data, for sending requests for web pages and sending information over the web page, which communicates to your computer, which communicates to the modem, which communicates to the rest of the internet. And of course, here there's more as well, goes on to wherever else it needs to go to. And the protocol are the standards for enabling that kind of communication. So as I was mentioning, there are several layers to it. We're not going to get deep into this, but there's a physical layer, which is the standard, or which is the standard for the transmission and reception of data over a physical medium, like a coaxial cable or another kind of cable. And there are other protocols, other standards of essentially structuring the data for applications, devices to be able to communicate over the network. So there's several media layers. So these are all kind of at the sort of physical level, the data link, the network. And then there's more sort of application level layers of the transport layer, session layer, presentation layer, application. So it's very complex. There's a lot going on here. And I just wanted to give us some overview of how these protocols in the communication over networks works. So I just wanted to sort of summarize some of the important ones here and kind of get this point across. So there is a physical layer. So the protocol specifies how the cable and signals should work, how the voltage should be sent over the the coaxial cables or the other kinds of cables to carry the signals. There's a transport layer which makes sure the data gets to its destination by establishing standards for dividing data into chunks, as we're going to be talking about, assigning addresses and correcting errors on the data. Some of this, I'm not really sure if it's correct to say that this is happening at the modem level, but perhaps this is a way to understand it. And the arrival layer or application layer. So there needs to be a set of standards for how data is going to be rendered into a web page or requested by a web browser or sent from an email application to somebody else and sent as an email and so on. So there are various layers and standards at different layers that need to be determined for devices to actually be able to communicate signals and translate them into the information we can read and understand. That's it for this one. We'll come back to this. We'll come back with more soon.